the bench where we're incubating discoveries. My name is Misty Good, and I'm the Division Chief of Neonatal Perinatal Medicine at UNC Chapel Hill. And I'm very excited to be co hosting today with Dr. Ben Fensterheim. Ben, would you like to introduce yourself?
Thanks, Misty. Yeah, hi. I'm really excited to be back for another episode. They brought me back for another. My name is Ben Fensterheim. I am an instructor in neonatology at the Children's Hospital Philadelphia. Um, and I am so excited to be hosting today's program with Claudia, Marcel, Nold. And I'm going to turn it to them to introduce themselves for the episode first. So why don't we have Claudia go first?
Yeah. Thanks for having us. It's really exciting, and yeah, we appreciate the opportunity to broadcast what we're doing. So my name is Claudia Nold. I'm a pharmacist by training, and then I thought pharmacy was a little bit too not inspiring, so I then decided to do a PhD. And yeah, stuck with immunology, and I'm a professor here at Hudson Institute of Medical Research and Monash University. And during my PhD, I met Marcel, and so I hand over to Marcel.
Yeah, hello, and it's a great pleasure to be here today. Thank you so much for the invitation, Ben and Misty. At this point, I usually say I'm the husband, and that's true. Claudia and I have been working together for quite a while, and I'm sure we will talk about this later on. Um, and actually, that while included starting off in Frankfurt, where we both trained and did our PhD and MD. So yeah, it's a bit of a boring lab couple background story in case you wanted to ask that later on. Um, but it wasn't boring. It wasn't a boring ride overall from there on or forward. Claude and I both did a postdoc in the US and then were recruited to Australia. And we've been running the lab together since 2009. I am, in addition to a scientist, I'm also a clinician. I'm also a neonatologist, like Ben and Misty, working at Monash Children's Hospital, and I've got an appointment at Monash University as professor of pediatric immunology and at the Hudson Institute together with Claudia.
I I love this. This is like we have so many topics to dig into, and I love that your work really digs into like it's really at the intersection of immunology and neonatal medicine and really therapeutic development. So this is going to be a very exciting episode today, and I'm thrilled also to call you collaborators and can't wait for you to tell the rest of the world about your research. So I know it's not going to be boring, Marcel. It's going to be fantastic. And so maybe you could start by telling us. So you mentioned that you started your lab together in 2009. What did you start working on? And then how has that evolved to today?
I go back a tiny bit more, which is to the time we had in Charles Dinarello's lab in Denver. And as most of the listeners would know, Charles is one of the godfathers of cytokine biology. He was really big in the IL-1, interleukin-1 field. And once you join that side of the river, you usually stick with it. Charles himself called it the IL-1 mafia versus the TNF mafia and so on, obviously jokingly. So we started working on anti-inflammatory cytokines then, and I had a friend, still have a friend, Alex Feldman, who at that time was working in Melbourne at Monash Newborn, and he and then acting director of the Ritchie Center, Philip Berger, started or continued their thoughts and discussions about the immunological problems that actually underpin neonatal diseases and specifically BPD, so bronchopulmonary dysplasia or neonatal chronic lung disease. And they felt that we would be a really good fit, Claudia and I, with the work that we've been doing on immunology and anti-inflammation. And they asked us whether we wanted to come to Down Under. So we actually had a visit to Melbourne in 2008, um, a 1 week whirlwind trip with, I think, something like 10 interviews or so in that 1 week. Um, and after that went quite well, then we actually started working, even when we were still in Denver, a little bit on the immune pathogenesis of BPD. And that's how it all started.
That's great. Claudia, anything to add?
Yeah, well, when Marcel said we moved in 2009 from Denver to Australia, we also moved as not two then after 2008 as three. So we had a 2 months old. And I'm just saying that for all women in science. So I thought like, it can't be too difficult. And as you are now working in NICU, yeah, it was also a bit rough, the whole delivery. You don't plan these things. And yeah, so we moved then here with the little Lars that is a US citizen. And because I wanted my anchor child because I love the US and it worked
Joke,
out.
joke. For all listeners, that was a joke.
No, because yeah, and it's really great to have multiple passports, I think. And yeah, so Lars then came with us, and yeah, I started immediately and set up an animal model, which was critical to do all the preclinical testing for IL-1 receptor antagonist because we discovered quite early on, as Marcel mentioned, and we were, of course, looking for IL-1 in the whole setting of bronchopulmonary dysplasia, and there was a lot in the literature out there as well um, to yeah, drive repositioning of anakinra for BPD. And therefore, you need a translational model. And yeah, so that was then my task that I wanted to achieve. And yeah, it worked out after a long time, but it did.
That's amazing. I'm really curious. That's such a big change to move all the way to Australia at a moment like that in your career with a new family. I'm curious, what were you inspired by to make that move when you did?
Um, well, you know, um, of course, because as a new mom, and we were discussing this probably, yeah, 9 months since during the whole time if we should do it because we didn't have family. And what inspired me is because I moved countries all my life, so I think this is my sixth now in Australia, and I always like to see new things and yeah, and just to give it a go, and also the opportunities because for a dual career couple, it's not easy to get a position, together at the same spot, as a lot of you probably know and have to make these decisions. And then especially for Marcel as well, because he wanted to work as a clinician scientist, and the opportunities there are difficult to do so, as you both probably know, and what it takes. And so it was a compromise. And I was open to go far away, down under. And the plan was not to stay for now 16 years. Yes, but that was the key, to achieve a career for both and the decisions that you have to make when you are a dual career couple. Yeah, and make compromises, and it all works out. You just have to believe in it.
And how did you decide that you wanted to study like similar things?
Well, maybe I just say because it was a symbiosis, because I was the scientist and Marcel was the clinician scientist, and usually you seek out for those collaborations and I think it's very, very important that clinicians work with scientists together. I mean, you don't have always the opportunity to marry one, which then also causes to discuss the things at the couch at night and at dinner table. And yeah, our kids by now know the word cytokines and lupus and BPD in and out, and and yeah, but that is the good thing, and you have complementing qualities and complementing yeah, not only personalities, points of view, how you look at things, and this is how you move things forward actually towards translation. Because I think everyone by itself couldn't do it, so together, I think it's possible. So that's why we stuck together and focused on similar fields.
It's amazing. It's like the prolonged lab meeting, right? Like all all throughout dinner and all day. It's really incredible. I love the symbiosis. That's terrific.
Yeah, I also just think clearly it shows how passionate you are for this work. I mean, to both invest so much of your time in thinking and talking about it is, it's a good sign that you're in the right field. Uh,
Yeah, no, that's great. Since we're talking about both of you, how do you decide when you want to, like, you were talking a lot about BPD, but how do you decide when you want to, like, kind of venture into a new field versus, like, stay focused? And is there one of you that's like, "Let's try this," and the other one that says, like, "No, we gotta finish this first?"
Hmm.
Yes.
That's a good one. Marcel, you go for that one.
Yeah, clearly. Actually, that's part of the symbiosis as well, because I mean, obviously, I mean, it goes without saying that it's not always a symbiosis, that there have to be discussions and sometimes passionate discussions. But yeah, no, absolutely. The distribution is that Claudia is usually the one who wants to really focus and stay focused, and see things through. And obviously, it's not that I don't want to do that. It's just that new opportunities do come around, and one of those was to work on NEC, necrotizing enterocolitis, in addition to BPD, which is where we started. And I think that you know, adding that part to our lab's portfolio was a good idea, and and Claudia, I'm sure, would agree with that. Well, I know she does. So, and she doesn't always, but on this one she does.
Yeah.
How did you
No,
all
and
decide
with
to do that, to, like, venture into neck?
yeah, because we had the opportunity as well that Sam Forster joined the Hudson Institute, and that was one aspect because he brought a lot of knowledge on microbiome. And I think decisions need to be as well as strategic, because especially when you're in Australia, when you need to ship samples, and you it also needs to work out. So he came, but then as well we got the opportunity in Frankfurt, that we had great or amazing collaborators in clinics that said, hey, we collect samples for you. You need to find the right people that you can drive things. And now we have you, Misty, and that is an excellent symbiosis because you need to, you can have the greatest idea. It's almost like in soccer, you want to hit the goal, but then you don't have the right players. They don't pass the ball. They keep it to themselves, or and if you have a great team, then you can also play the sports, I would say. And this is how it all started, because we had a conversation over a beer when we were back home in Frankfurt, and then good connections to the surgeons. Then Sam came, that you also work with together, and yeah, so this is how it started. So it's not it's a, sometimes you have to be at the right place at the right time.
And then of course, also just to add to that, in the wards, although thankfully NEC is not very common, and our unit Monash Newborn has very low NEC rate, we are still one of the surgical referral units. So number one, we get referred babies with NEC or other surgical problems of the gut, and then also sometimes see our own babies develop NEC. And there's, of course, a relationship with chronic lung disease. In the babies who have NEC are much more likely to proceed also to have bad lungs, right? So the clinical context there also intrigued me, and studying whether BPD and NEC are similar in terms of the pathoimmunology or not is also one of the really big questions for me, at least in this field, that I think we can make a contribution to answering.
Yeah, and another aspect that I now came back to my mind as well is that since we worked on interleukin 37, and that has an anti-inflammatory agonism, and was, the papers came out that one that we co-authored, that it's beneficial in inflammatory bowel disease. Um, we we thought, well, then it might be also, good for neck, and therefore then as we were developing at the same time, or are still IL-37 as an Fc fusion for drug purposes. Yeah, so that was the niche. And then with Marcel, uh, I'm talking as the scientist, because we need to work with clinicians, and that's why there's no point for me in doing something where there's not a symbiosis with clinics. And that's what then was like, okay, yeah, let's look at neck as well, and this is how it started. And then the paper in 2022 came out. It's about neck.
I love that. I love how you said you have to be in the right place at the right time. I think it's really incredible. And just thinking about, getting introduced to you both and now, we're talking all the time, co-mentoring a grad student and really trying to solve neck together. I mean, we do see it still. Like last night I came in and got a patient sample from a surgical resection. And so, I mean, we're still seeing it, being a referral center and um, we have to do better for this disease and all the complications of prematurity. Definitely.
I just presented yesterday our study at the pediatric surgeon department at Monash Health as well, to always make the registrars aware that rotate, that we need samples, how they should collect them. And I also had a photo of you and the others that are working with us, that we can only tackle this together. And yeah, in science, one has the samples, the other one got some funding, and since it's things have become difficult. If you have a patchwork, then, or it's almost like a puzzle. If you put it together, then maybe eventually it becomes a picture and things become clearer. And if you work together, um, so how we're trying to do so now, it's the collaboration and help each other out when the other one is in need. I think that's how you at the end achieve to help the patients. And yeah,
I, uh, I think it's really amazing. A few things that you said. One, that a lot of what you're doing now is motivated by kind of clinical observations that you experience with the patients, but also, I think kind of a shout out to the immune system. And you're noticing that patients with neck have an increased chance of getting lung disease, and that there must be some connection between the gut and the lung, and that there may be shared pathology. And I always think about the immune system when I think about shared pathology between organ systems. And um, it seems like such a natural place for you guys to go if you're immunologists and not necessarily organ specific. Now you're really just studying these systems that can cause disease in different locations. So
No, I was just going to say, you used the word systems, Ben. Um, and yeah, that's actually one of the things we're trying to, or one of the research areas we're trying to move into more now, which you can't really not do any longer in this day and age of large data sets and omics technologies becoming more and more available, even though they still cost an arm and a leg. Um, and I'm actually just working on frantically trying to finish off a paper in which we really try to take a systems biology view on using a large number of flow cytometry data sets and a 11,000 macroproteomics data set all together to understand what's going on in terms of, well, activities of a drug, anakinra, in babies, as well as what's going on clinically. And I forgot to mention, yes, one of our postdocs and also a clinician scientist, Scott Stansfield, has managed to overcome the hurdles of a certain EMR that we use at Monash Health and extract massive amounts of clinical data as well. So there's the third omics. So putting that all together is a huge challenge. And me not being a bioinformatician makes it even harder. But I think it's becoming more and more important, and that will actually ultimately allow exactly those insights to see where are the commonalities, where are the differences, which are the patients that develop NEC or don't, and those that develop BPD or don't, or actually, for that matter, white matter injury of the brain, which is another complication that we are not directly working on in our lab, but also with collaborators. You shouldn't neglect the brain, really, should you?
yeah, I think there the systems immunology or the systems biology is a blessing and a curse. You know, every time I've engaged in a systems project, I think, oh, yeah, I'm definitely going to discover the truth. I'm looking at everything. How could I not? But then at the end of the day, while I do learn a lot, I'm still left. You still have to do mechanistic biology to really actually show that one protein does one thing, and because that's ultimately what we can bring. So that's amazing. I had a similar experience when I was in graduate school, and then I went to and it really systems biology was just starting. Bulk RNA sequencing was just becoming a thing. And then I went back to medical school, I went to residency, I went to fellowship, and I came back and I was like, "What? You haven't done single cell RNA sequencing yet?" So, and that had all evolved in the meantime. So it's amazing that technology is there, and I think merging that with more classic forms of scientific discovery is
And without
the
directly
task now.
asking your age, Ben, I'm sure you are actually a digital native, whereas others in this call are not. Yes, I actually remember when I wrote my thesis, I still went to the library and photocopied papers to then highlight with a highlighter. Yes, I mean I didn't have to like my supervisor actually write the print or type papers with a typewriter on paper and then send the physical paper to the journals. That was a previous generation, but still, I think you've got a bit of an advantage there.
Yeah, but even now, you're right. I have always had access to the internet since I've been in science. So I've had paper, and now it's just the click of a button, and I get the paper, and it'll find exactly what I'm looking for. But I feel still blessed to have that. And yes, things have changed. Actually, that relates to a question that I was just curious in general to ask you guys about. But how you think science in neonatology, because that's really been your focus the whole time, but how science in neonatology has changed over the time period since you've started your work and today. I've even felt a change just in the last maybe 5, 10 years since I've been interested in the field, and I'm curious if you have as well. Maybe you're in Australia, so maybe not. Maybe it's different, but I'm curious if you've noticed changes in the field and which direction you think the field is moving into, and comments on that.
I have a practical answer, which was really important for me as at the bench, is because Marcel then had these ideas about studies, and he was like, "Oh yeah, we get 500 microliters of blood, and then we had these little amounts of plasma, and then in when we were started working on it in as Marcel mentioned in Denver." We were establishing together with R&D Systems those protein profilers, which still required 100 microliter of plasma. So from the practical perspective, I think we have way more opportunities now because you can go down to 5 microliters on a bench assay, and you don't have to do mass spec or something as it was. And I think that just opening the opportunities to do research in that field because of the practicalities. Um, because any idea if you have a roadblock where it's like, okay, you don't have enough sample. So I think that opens every door, I would say, what we can do now with very, very little samples, or even in neck, when we just get a tiny, tiny piece of a donut, you can do so much now. So that is from my scientific perspective. And then, yeah, you you can answer almost everything now when you have the money and a tiny bit of sample.
From the clinical perspective, I think there's also been a shift, which actually is, in my opinion, going very much in the right direction, and that is to recognize that, yes, preterm babies are at the beginning of their lives, and we have to be very careful what we do, and they can't make their own decisions. Nonetheless, that's not a justification to deprive them of medical progress. Yes. And I think the field is moving in the direction of actually recognizing this fact that preterm babies do deserve medical progress just like any other patient and any other person. And that with the right safety nets in place, then the clinical trials not only can happen, but actually should happen.
I agree. I couldn't agree actually with you more. I think babies do need science, right? And everyone talks about they're a vulnerable population, they're very fragile, but they do need like our advancement and, new medications and novel therapeutics. And you brought up clinical trials and previously anakinra, and I was excited to ask you about that and talking about, I was wondering if you could walk us through like your, bench to bedside journey with that. And when you think about the neonatal immune system and impacting that with the therapy, and I know we talked about biomarkers, so there's so much to dig into with this discussion. But, do we think that there's an immune related biomarker that would tell you, the timing that potentially anakinra or another immunotherapy could be given? And what are your thoughts about that with your work at the bedside?
Okay, let me start with how the journey went. So essentially, we touched on the early parts, which was really that we came from an IL-1 lab, and then anakinra, with its very well established safety profile, that actually has disadvantages for other populations, such as it's not as quite as active. You need to give it more often than TNF blockers, for example, and you need to inject it subcutaneously or IV. All these are disadvantages for adults and older children, but in a NICU, intravenous administration is something we do all the time, and we monitor the babies continuously anyway. So a short half-life is actually a good thing, because then when you stop treating, then the drug leaves the body very quickly, and you don't have an antibody that lingers for a month, right? And of course, infection, that, as you mentioned, was one of the main concerns that we needed to think about. So we really took the long way to be sure that we were doing the right thing, and essentially starting to work on understanding the role of IL-1 and actually building on the work of others, of course. And that's also super important to say, right? That it's not only you. So it's actually great if others show similar things and validate your concept, because you don't want to be the only one showing something. So yeah, starting to work on IL-1 in first BPD, and then later on other diseases in 2008. And then the first clinical trial that anakinra pilot started in 2022. So that's quite a long journey. But I'm really glad that we did it this way, and also along the road started collaborating with fantastic experts in their field, such as Carl Kirkpatrick and David Metz, who are pharmaceutical scientists, and David is also a clinician, nephrologist, and clinical pharmacologist, with a lot of knowledge in clinical trials. And then Rod Hunt, also great knowledge in clinical trials at Monash Newborn. So we really had the right team in place to then move forward with that first clinical trial. And that was really, really super important, and made us feel so much better that we were actually doing the right thing in terms of the right drug, the right patients, and the right doses as well. So yeah, lots to talk about on that, but I'll stop there and move on to your second question, which was around biomarkers. So yeah, it's actually related. So at the moment in AP1, we gave anakinra essentially prophylactically. Yes, right. And to the babies at those gestations where the risk for disease is highest, so that the risk of a new drug is actually justified. Yes. It would, of course, be ideal if we had a biomarker to show us which babies will benefit from anakinra, because, I mean, it would be naive to think anakinra is now the magic bullet. Of course it isn't. There are no magic bullets. And this is one of the paths that we're also working on. So we are, through our proteomics that I mentioned earlier, we are looking which mediators are actually changed with anakinra, and how the anakinra babies behave in terms of the proteome and also the flow cytometry, and then understand this better. But I think this will require I know that will require a larger cohort, and hopefully we'll be able to do this in the phase 3 trial that we are also planning. And then out of that phase 3 trial, not only show that anakinra is safe and effective in treating hopefully several complications of prematurity, but also understanding which babies would benefit the most.
Yeah, I just want to comment on, because maybe, yeah, early career scientists or mid-career scientists listen to that. And then you always, when someone after 10 years or 12 years tells you a story, it's always like a German Autobahn, it's like a 200 speed and you go and this is where you arrive. It was not like all like that. And especially establishing models and then changing time points in preclinical models. When are the cytokine the highest? Endpoints of harvesting, complicated, especially in neonatal preclinical models, are very, very difficult, as those know that work with NEC or BPD. Just to get mice time-mated is sometimes a disaster. So don't give up. This is my message. And then just really try. And I remember at one point we were like, okay, that's it. And we had this massive discussion, almost fight. Well, actually we fought. And we had the discussion about, yeah, let's just chuck this whole thing. And then I was like, no, we try one more stuff. And yeah, and that then at the end worked. And this is, yeah, don't give up, keep going. And as long as you breathe, you fight, you just, as long as there's funding. And yeah, so that is my message. And we had an amazing PhD student at the time, Christine Bui, and I want to mention those people. And Ina Brutloff, that goes down with you and inject mice even over Christmas. And yeah, so yeah, and that is a message as well that I want to get across. It's not an autobahn. It's just off road.
That's fantastic to hear, and I think shows, the value of what you're saying. I mean, it'd be so easy to get an idea. Oh, I wonder if I do one experiment with this one cytokine blockade and see if it works, and then it doesn't work, and then you move on. But rather, you trained in an IL-1 lab. This was something that you were experienced in. You weren't about to give up if one experiment or two experiments didn't go your way. You spent time and really developed the story, really understood what was going on. And it was through that persistence and understanding that got you to the point where you said, oh, hey, this actually really might work. And I think the commitment to in the long term really shows and was probably key to the success that you've had.
Yeah, and you have to have others as well, and this is probably as well in the team. So as long as one doesn't give up, because always one is, sometimes I was like, I'm not doing this anymore. And then Marcel was like, no, let's keep going. And then, yeah, the other vice versa. So this is why it's always team, and then someone has an idea. So yeah.
Going back to the symbiosis, when one of you is really resilient, then the other one is ready to give up and you kind of balance each other out. I love that aspect of the story. I was gonna ask so many questions about the preclinical models and how you determined like the timing and dosing strategy. And but but really I want to ask, how did you not give up? Like that is I think one of the hardest decisions that I have to make as a PI is like when to pivot and like when to let someone like a graduate student, for example, like go down the rabbit hole and you know, I want to get them out, like save them and not waste time.
I don't have a patent answer for that, but I'll tell you a little story here about my very first um, endeavor in science as a medical student still, which is what you generally do in Germany. You start a thesis during and try to finish it during your medical studies so that you are actually allowed to, at least in that time, that you're allowed to call yourself a doctor, because otherwise you're a physician, but not a doctor, which is weird to patients. So yeah, that's what I did. And I went to a lab that was very much a basic science lab, and an anatomy professor by the name of Oelschläger, um, who was fantastic in getting me excited about a project on African mole rats. Sounds very odd, doesn't it? So these mole rats dig tunnels that are completely straight for kilometers, without ever coming to the surface, and they are essentially blind. So his reasoning was that there must be some sort of magnetic orientation system in the brain, and he thought that would be a really cool project to work on, and I agreed. So I started, and yeah, not many things went right. The antibodies didn't work. Then equipment broke down, and even though everyone did their best, including Professor Oeschleger, the project was really not moving along. And generally speaking, medical student projects at that time were supposed to be pretty short, generally speaking. But I was prepared to do more. Yet Professor Oeschleger said to me, "Nee, you should probably move on. So pivot, as he just called it." And then he offered me a project which didn't excite me. And yeah, I disagreed with his decision to take me off that project, but in the end, he convinced me also that it wouldn't be smart to, invest that much time in something that's so uncertain. So I left his lab, which we were both a bit sad about. It did something else, which then was immunology and was really exciting and turned out well overall. Um, in the end, though, this project was published in Science by someone else in Professor Oeschleger's lab. It took them another sort of 3 or 4 years, yes, but they found this magnetic orientation system in this rat's brain, and it got published in Science. So, who was right? I don't know. And I guess that's why this story fits, right? Because where is the right decision? Was it right for me to stop? Was it right for him to say to stop? I don't know. I don't have an answer.
I also love the actual metaphor of these animals digging without knowing where they are. If that's not the perfect metaphor for staying in science, I don't know what is.
That's great, but I had not thought of that. That's really good.
And then you find a little nugget, and then you're like, yeah.
Yeah, so both of you have trained so many, like, students or, like, career investigators, so I would just any advice that you could, you know, um,
Yeah. I think
give for
sometimes I know it's not scientific, but for me, sometimes it's a gut feeling as well. Sorry with neck. Then- but yeah, it's just, I don't know, I don't, yeah. Yeah, you go for a walk or a run and you think about it, and then, yeah, that's how I do it. But maybe that's not very scientific.
I think those are great stories. Something I'm thinking about, all the time too, as I make important decisions about my career. It's great to hear a story like that. Um, I'm,
I,
I'm
sorry, Ben.
no, go ahead.
No, I was just going to say, I mean, of course, luck, gut feeling, they're all really important. But then also you can, I don't know if force is the right word, but you can force your luck to some degree. Yes. Um, because luck, there's a German saying that sayings usually don't translate well, and I don't know the English one, but essentially it means that you will be lucky if you try hard. Yes. And this is one thing I do say to everyone who starts in our lab that I get to actually talk to, and Claudia and I sadly cannot co-supervise students anymore, so we have to do these things separately because of rules around married couples. Don't get me started. But it is what it is. So yes, I say to those students that what you get out what you put in. Yes. And this is just how it is. And even if you're not lucky, then you will have things to write about, to talk about, to present. And that's alongside trust, being able to trust each other on all levels and with all team members is probably the most important aspect of early career projects that we have in the lab for us.
No, I think that's great advice, definitely. And, I was gonna ask because Ben was saying, he's a new instructor, and so any advice that you have for someone at his stage starting his career, really excited about science, it's easy to get discouraged in the funding climate, but what would you tell Ben and everyone else listening? If what do you wish somebody had told you at that stage of your career?
I think it's really important that if you want to be a clinician scientist, it's really important that you're passionate about what you're wanting to do and being a clinician scientist, because it is a huge investment. Yes. It is essentially doing two careers, and you only have 24 hours like everyone else in one day. So you have to do more, you have to invest more than others if you want to do it right. But if you're passionate about it, then I mean, for me personally, it's the best thing you can do in in terms of job in your life. This is what I've always wanted to do. And actually, this goes back to one of your questions at the start. What was I passionate about when I started? It was actually doing what I do now, as in work in the wards, see the patients, understand what the problems are, and then do what I can together with a fantastic team to try and solve it. So if you're passionate about this, then things will fall into place. Another important aspect is find the right team. And if you're starting your career, then of course that's really hard because you don't really know who you will be able to work with well. And yes, you can get advice from others about who is a great mentor or supervisor, but then you need to click with them, right? So make your decision consciously about those things. Don't only talk to the supervisor because you will be working with their team a lot more than them. And yeah, then once you would find your place, then stick with it, and then you will be rewarded.
Uh, you get the scientist view of me. I think you clinicians have an amazing opportunity because, as Marcel said, it's tough that you have two jobs, but you have also the safety net that you can always go back into clinics, so you're not, you're losing your job. And I mean, in some countries there's tenure track, in others there's not. So, for example, in Australia, it's super difficult. It's fellowships until you retire for most of the scientists, and if you're not in the 8%, you don't get fellowships, then you have to live from others. So that is the opportunity that you have. And what you also have is, which I miss because while I was doing my PhD, I was always working in the pharmacy as well. And then you have the patient aspect where someone is really happy and grateful, that you do something for them and you get feedback, which in science, as you pointed out, when do you know when to stop when things don't work? It's always this rejection, it doesn't work, or this, and then, yay, it's working, but then 10 times again, it's not working. So you definitely, and I see that with Marcel, you have more of a balance to things. So that is one aspect that it's important to consider for clinician scientists. And I don't want to whinge to be a scientist, and I don't have that anymore, but I can see you just have, that we have that less, that patient aspect where someone is happy. Of course, there are not always nice patients, but see that as an opportunity as well, that you don't, as and a lot of scientists say that you have to look for a balance towards the difficulty of science so that you don't go nuts. Yeah. So yeah, you should. I think all clinicians should do science because you have both opportunities. You can have always the fallback. You can drive things. You can work with. It's more yin and yang.
I think those are all I've taken them all to heart. There it's great to hear. I mean, and clearly the path has been very fruitful for both of you. And it is true. I do really wish more clinicians were in science. At least right now, it's a small group of us. It feels like a small group of us compared to science at large in neonatology. But the people that are there are really passionate, and it's a great group to be around. Um, I also really, uh, hear the comments about finding the right people. I mean, I think that and finding the right mentors, it can totally change your perspective. I know for me, as I've been trying to do my work in a very individual way, I just recently decided I was too lonely, basically. I was too independent. I wanted to work with my friends, and I've been training for so long, doing my own independent work, getting my independent money for projects, and so on and so on. And I just started working over the last year with a friend of mine. It's a true collaboration on a project. And it's like reinvigorated my passion for science because we can both pick each other up when we're struggling and help each other in the in our weaknesses. And so I really feel what you've mentioned. I think all that's great advice.
Science is a team sport, and I always say do science with your friends, and it will make everything better, because if you have a bad day or a grant doesn't get funded or something like that, like, you're in it together, and you can, really pick each other up and keep going. Well, we always like to close talking about, the personality of the lab or any fun things that you like to do together. And I don't know if you have any lab traditions you'd like to share with the group?
Um, yeah, we try to do things together with the students, and it has become a little bit less more that I would like to have it because of yeah, funding as well. Because and even across the university is, as you understand, retreats and so have been reduced, and you sometimes think Eliza or fun, but we do things. We do things
This is exactly how she thinks.
well,
Come on,
yeah,
Eliza's
because
are
you have
fun, right?
yeah, especially if you look for interferons, it becomes like a $3,000 fun. Anyway, so we do things. We go bowling together, and or uh we did uh what was it, a casino event, where we were playing poker and roulette, and yeah, we do stuff like yeah, with the team. Or we went to an axe throwing, which I really wanted to go, but I couldn't, I think, because one of the kids were sick. So yeah, so that's what we do.
We did an axe throwing. That was a good, like, stress reliever, I think, the axe throwing.
Yeah, yeah, I think we should do that one again.
We recently did laser tag, and, that was I'm a little bit too old for that, I think, now.
Oh, I would love it, because but Marcel has this is so strict. I mean, even the kids couldn't have. I had to smuggle Nerf guns in the house, so he was totally against it. But I would love laser tag, and oh yeah, I'm full for it.
Yeah, I know you would, but
Yeah, but well, you are father of two boys. What are you supposed to do? I mean, I love
but
this stuff.
don't shoot each other. I think is an important learning life lesson, right?
That's one of the originals. Yeah.
Yes, it's true, but I mean, yeah, if as
Oh,
long as
that's
they don't
good.
shoot at you.
Actually, one other thing that Claudia reminded me of is we went cherry picking also, and I thought you can't cherry pick your data, so you actually have to go pick cherries.
You gotta get it all out in the field, so you leave it away from the lab.
Yes, and we've got great orchards around Melbourne. So if you ever visit, hopefully, then in summer particularly, then that's always a fun activity.
Then I think that was just our invitation to come visit. I feel like we need
All right.
we need a
Yeah,
trip to
Uh,
Australia.
yeah, I can promote the cytokine society, the cytokine meeting in 2027 in Sydney. So that is happening next year, and that's a great opportunity for those that work in inflammation and cytokines and want to come to Down Under. So look out, it's going to be advertised soon. So cytokines in Sydney,
that's
from
amazing.
Cytokine
I'm writing it
Society.
down.
We will be
Yeah.
there.
Abstract is gonna go in.
We will be
I've
there.
never
That's
been, so
terrific. Well, I think with that, we will definitely close, and hopefully we'll see everyone at the Cytokine Society meeting. That would be great. But it's really been a pleasure, Marcel and Claudia, to host you on At the Bench, and we are just so honored to have you and hear all about your research and your journey in science and together having a joint lab. It's really remarkable. So I applaud you for all you do and can't wait for all the future discoveries of your team.
And thank you so much. It's been a great pleasure.
Yeah, thank you for having us. Nice to meet you, Ben.
Yes. Thank you all, and thank you for the advice.
Thanks.
Great speaking with you.
Thank you so much to our listeners, and we'll see you next time on At the Bench. Take care.